Hello and welcome to this webinar replay of the geometric design of a highway using Civil3D. My name is Henry Barnabas, and I, at the time of recording this video, am a project engineer with Tractor Nigeria Limited, a prominent road construction company in the northeast of Nigeria. I've been designing highway infrastructures for over 2 years now. That is not small a time, because I've been part of the design of the first grid interchange in Yola, Adamawa State, and it comprises of flyovers, underpass, and pedestrian bridges. I designed the performed the geometric design. So, and I've also designed over 9 roads from start to finish, right? So, in this webinar, I have taken you through a comprehensive overview, right, of the design of a highway using Civil3D. That is starting from importing your points through to your design, and then eventually extracting your design data for setting out on site. All right. I've also shown you how to import your design codes that will automatically be checking your design while you are working on it. Yeah. All right. So whether you are new to Civil3D or new to road design, or even both, this video is exactly what you need to move you from becoming a novice into becoming a very good highway design engineer. And also, if probably you're already been designing, this video will help you learn some valuable insights from my experience, because I've been designing, and I don't just design, I also supervise the designs during their construction, and also perform revisions where necessary. So you would be learning from a hands-on project-based design. All right, having said that, let's get into the video already. So these are the design steps. Okay, the design steps. First, we are going to, the step 1 is familiarize ourselves with the survey data. You have to know the survey data that you are working with very well, so that you can accurately import them to Civil3D. Then secondly, we are going to be setting up the Civil3D workspace. Then thirdly, we are going to import these survey coordinates. Fourth, we are going to create an existing ground surface. Then fifth, we create the horizontal alignment, and then proceed to vertical alignment. Seventh, we are going to create offset alignments and widenings and intersection. Okay, then in step 8 we create assembly and create corridor and corridor surface. Step 9, we are going to compute the materials that are required, our cut and fill, and then we'll create our cross sections. Then step 8, we are going to generate plots and reports. All right, welcome back. So this is where we get ourselves familiar with our survey data. Okay, so based on the design steps. So if you see, we have 5 columns here. This is column A, B, C, D, E. Now these are the descriptions of the columns. This is the point numbers, or P. Then this is the eastings, which is E, and then this is the northerns, N, and then this is the elevations, Z, and then this is the description, D. P-E-N-Z-D. Let me just write it here. P-E-N-Z-D. Sorry, D. This is the point code. You know, I'm just saying this because you will see it shortly when we go to Civil3D. You have to understand how your points are arranged. So it's arranged in this format here. P-E-N-Z-D. Points, easterns, northerns, Z, elevations, and then D, descriptions. So what are these descriptions? We have CL here. CL means center line. So if you go down, you will see GRND. GRND is short for ground. Okay, so yep, as we go down, let me go down faster. Oh wow, we have a lot of ground points here. Yeah, of course we should. Then ST is stream. Okay, I know this because I took the survey data with the surveyor. So all right, so then of course the surveyors will give you the descriptions. Okay, they have to tell you what the point stands for, so that there should be full description, but for now we have this.
like this. So this is str stream, okay. So and then we have tr somewhere here, okay. Yeah, 3. We have 3. I usually take the points for the tree, so that if I need to avoid some trees, avoid cutting down trees, I will do that, okay, because I will see these points in my workspace, okay, which is important. I encourage you to always do that when you are designing. Take the coordinates of the trees so that you can preserve these trees. We don't want global warming. All right, that's on a lighter note, but very important. Okay, so let's move on. So this is an Excel file, but it will be saved as a CSV file. There are 2 ways you can import your drawings to your points to Civil3D. It's either going to be in text format or a CSV format. Okay, so but in this case I've saved it as CSV points, so I'll not save that. So this way I've saved it, okay. This is the name. So now let's go to Civil3D already. So okay, so here is my Civil3D. I've just opened it. All right, so this is Civil3D 2023. So like I have said, I think I said, if I've not, I'm saying it now. So whatever I'm doing with this Civil3D 2023, it can be done with any lesser version. So you must not have Civil3D 2023. Of course, there are advanced tools that you can do with Civil3D 2023, but it's not related to what we are doing now. All right, so if you're having from 2015 up to 2023, you can do everything that I'm going to do now. So what you do is you create your new file. Okay, so we have this workspace here. This is our Civil3D interface, our workspace. All right, so yep, if you look here, it's similar to AutoCAD, just normal AutoCAD, but of course it is having Civil3D capabilities. You can even switch to AutoCAD from here. If you just click on this drafting and annotation, it becomes AutoCAD. Yeah, that's it. But once you switch to Civil3D, it brings in all these complex ribbons. So it's not complex too much like that. These are similar things if you have used AutoCAD, but you have place to create alignment here, which is not in AutoCAD. Okay, so and then right here by my left, you would see the tool space. Okay, this is a tool space. It has 4 tabs, which is a prospector, settings, survey, and toolbox. So we're going to be using some of them in a short while now. So now the first thing you are going to do is to set up your workspace. Okay, first of all, let me save this drawing. I'm going to save this drawing. I press Ctrl X, Ctrl S. Okay, let me go to my desktop yep. Okay, let me find some way to save that quickly in my local drive. Civil3D project, Civil3D webinar. Let me just save it here. Let me call it webinar road. So save it anywhere you can locate it. But this way I've saved mine. So I've saved it. So automatically you see the name has even populated in this prospector tab. So the first thing is to set up your drawing. Go to settings and then go to the on this webinar road, the name, you right click and do edit drawing settings. So it brings up this wizard or dialog box. All right, so you will see under the unit and zones, you'll find the drawing unit to be in meters. Okay, so we are working in meters because I'm in Nigeria. We use metric. Okay, by the way, this Civil3D is Civil3D metric. Okay, so we have Civil3D imperial. If you install Civil3D, it installs automatically metric and imperial. So but I'm using metric because we use metric system here. If you're in the US, you are going to be using imperial, of course. So this is in meters. Okay, everything here is in meters. So if I have any foot, okay, if I have imperial unit which is in foot, it will convert it to meters for me using this conversion rate, which is 0.304 whatever per meter per foot. Sorry. So this is the default scale. So you can change it, but no need. All these things can be left default by default. All these things. So my angles are in degrees. All these things gives you on default what you need. So you may not be making any change here. Where you're going to making change is in the zones. Okay, under the zones you have your datum. You have to select a datum. So where are you working at? You have to select the country where you're working at. I'm in Nigeria, so I'll scroll down to Nigeria. I can just press N to snap quickly to where N is. So I have found Nigeria. Alright, so then on the coordinate system we have about 6 of them on this drop down menu. In this drop down you can see, but we work with UTM zone 31N. Okay, there's a reason for that. It's just what we usually work with in Nigeria here. So once you do that, every other thing here is populated, so you leave it. Now I'm not going to go into these other tabs because there are things you can set when you have been frequently working with Civil3D. You might find the need to come here and set some things before going into the design. So you can set the layer, whatever here. So let's just go, let's apply, and then okay. So we have set our drawing to our coordinate system, and once you do that, automatically you will see that this geolocation over here appears. It won't appear if you have not done this. Okay, it allows you to also, you know, on this geolocation you can open your maps and things like that, but I'm not going on to all of that. All right, so let's go to import our survey points. All right, so you can import your survey points in 2 different ways. Okay, you can import it, number 1, as a COGO point, that is coordinate geometry point, or as a survey point. Now a quick difference between survey and coordinate points, COGO points are, in COGO points you can easily move the points around in the workspace, but when you import it as survey points, you cannot move it. You cannot move it because until you use specialized commands. Now again, in COGO points it is local to your own file or your own laptop, but when you import it as survey points, you have the opportunity to collaborate with another person using working on the drawing, because you can be able to save the points in such a way that in a cloud system where another person can work with it. Okay, right, so that's just the quick difference between survey points and COGO points. So now under these survey points we have, okay, let me just import it as COGO points. All right, because going through survey points is quite tedious and I don't want to take too much time here. So let's go to the prospector tab. We have the points. All right, under these points you right click on it and then create. Okay, it brings up this ribbon for you. You have all these stars, from about 6 of them, 1 2 3 4 5 6 7. So the last one, okay, is what you are going to take. If you hover your mouse over it, you will see it say import points, so you import points. All right, so if you look at this, okay, if you look at this, you have to select the file where the point is located at. So it takes me straight to where my points are, but this will not happen if you have not previously maybe worked on that folder. So you have to, you know, use these things here, you know, to navigate to where the folder is. So this is my point directly, so I open it. Okay, if the points, if it was set up correctly, it will show you a check. Okay, but if there's an error with the way you saved your file, it will not be able to upload. So remember, I said the points are, you have to put the point format. Now you have to select the point format. It's PENZD. So let's look for that here. If you go down, you're going to see PENZD. Very good. So look at it, and it's comma delimited. Okay, you would have another format which is maybe not comma delimited. If you open here, you will see a lot of other formats. Okay, you have space delimited and comma delimited, but we are using comma delimited because it's CSV file, comma separated value. That's what CSV means. So if you just click on that, you will see it will preview those points that we saw on the Excel. Look at them. Okay, these are the points number, and then these easterns, northerns, points elevation, and the CL. So once you have done that, you go straight. Leave all these other ones unchecked. Okay, right, because there are some points where you need to add them straight to a group, but we're not doing that now. Let's just add them directly. So you just press OK. Okay, so once you have done that, the point is somewhere in your drawing. You can close and then press ZE. Okay, once you press ZE, you enter, sorry, ZE, you press enter. It will zoom straight to where these points are. Okay, look at the points. Yeah, right now you don't see which points the descriptions of the points. Okay, you can add the descriptions to the points. It's only the 3 points that you can see descriptions. That's because of what we call descriptions key sets. Under the settings, you'll find something under points, description key sets. Okay, this is where you find, but I'm not going to that. All right, let's just go on. I don't want to complicate this thing, please. Let's just go. It's simple. All right, so let's have our points groups. You see all points. When you expand it, you see all points. These are all these points. They are all grouped into this all points. So if you right click on it and go to properties, you would see the under information tab, you see the point style. Okay, and then you have the point label. So for now you don't have any label, that's why it was not labeled. So if you choose, let's say, elevation and description, and then press OK, you will see that it automatically populates, you know, the descriptions of these points. So you can see all these points and see what they mean. These are stream. These points are, this point is called stream. You know why I took these points? Is because, you know, in the roadway, you know, sometimes water is passing across the road. Okay, all right, if it's an existing road. So you have to take those points so that I can see the elevation, see the direction. Okay, so that I can place my box culverts accurately. All right, sometimes your box culvert will be skewed. That is, it's not going to be perpendicular to the road. Okay, it can be skewed. For instance, in this place, I'm sure I'm going to have a skewed box culvert. Okay, so that is the reason why I have taken the stream points. All right, so yeah, so that's much about the, you know, the points. So if you see the points, the description are overlapping. Okay, that's because of the scale. If you reduce the scale somewhere here to, let's say, 1:200, you will see that these points, you know, it's more, yeah, it's not overlapping. It's not so big like that again. So let's go back to 1:1000. That's what I'm working with. So yeah, that is it for this. So let's now go to the next step, okay, which is to create surface. Now before we go to that, now I have center line points. Okay, I want to work with the center lines. These are the existing center line. The existing center line, of course, as you may know, this is an existing roadway that has not been designed. So you know, you take the proposed center line, okay, the existing center line, which is, you try to, you know, follow the existing center line, of course, when you are designing. Right, so I have to group all these points in the center line. As you can see, it's here, somewhere here, and then there is another one here. So if I say let me be checking them, I would have issues because I will not be fast enough. So let me create a group for all the center line points. So I'll right click on point groups and go to new group. So on the names, I'll call it center line. Okay, so when you go to the point list, you don't see any points here. That's because nothing has been added here. So let me add it using all the points with raw description ending with CL. I put asterisks. Okay, once you do that, you go to point list. You see in that it takes only all the points that have CL. Okay, so once you do that, you apply and then you press OK. So you see that point group here. So click on that, right click on it and do select. You will see it have selected all my center line points. It have highlighted all of them. And let me do something, isolate. If I type isolate on my keyboard and then press enter, it will isolate only the center lines. So this is my existing center line. Of course, it looks like it's a very nice part, but when we are designing, we may see that the curves that is kind of coming here may not be sufficient. So it's going to, of course, be based on our design code. So that's it. Let's move on. Let me unisolate. Unisolate. Okay, so I have all my points back. So that's the good thing for creating point groups. I like doing that. Now I will create point group, okay, for all these points categories. Remember when we reviewed our points, our survey data, you should know all the points descriptions and then create a group for all of them. Okay, I won't do that now. Okay, so sufficient is the center line. Now the next thing on our design procedure is to create the surface. So still on the prospector tab, let me minimize this. You have the surfaces. Okay, you right click on the surface and create surface. We are going to create a thin surface. Okay, automatically it gives you thin surface. So, and the surface name, we are going to name it EG surface. EG surface. Okay, then you press OK. Now you have created the surface. You will see this button comes up for you to expand and then see that surface you have created. Okay, I've created it, but there is nothing showing because you have not added any points to the surface yet. So you have to expand the surface. You find descriptions, expand descriptions, and then you find the point groups here. You right click on the point groups, add. So it brings you all the groups that you have. So far we just have 2 point groups. That's because we only created one more, which is the center line. And remember, this center line is still contained in these all points. It's not like it took it away from the all points. This all points is all the points in this. So this is what we're going to be creating our group surface from. So we press OK. Now you see our surface. This is our surface. Beautiful. But it's triangulating over a large distance. You can view this surface. Okay, this is what I like doing always when I'm designing. I kind of visualize what I'm doing. So if you press object viewer, you can see the surface. Okay, yeah, as you can see, this is relatively flat. That's why you're not seeing as if there are variations in the levels. Okay, if it was continuous, you will see it showing. Okay, but I don't like the way it is because I don't have data around here, but this surface have triangulated all these places. I can delete it, but I have to first of all change the surface to triangles. Okay, I can find that here on this modify tab. You go to surface properties, and then you will see the surface style. Change the surface styles to contours and triangles, then press OK. Okay, then you can use this edit. Okay, edit surface and then delete some lines. Okay, I'm going to be deleting some lines like this. Okay, I'll press delete. Okay, hold on, I'll just delete some lines. Okay, I'll delete. Sorry, press enter when you have highlighted some points. So you can see the surface is coming fine now. The boundary, okay, is coming fine. So make sure you don't go too much into your proposed roadway. So I will do that continually until I have a very fine, I'll remove all the excesses. Okay, but let's just move on. Okay, at least you see how to do that. You can do that for the rest. At least it will not jeopardize our design. Okay, for now, yeah. So let's move on. We can now proceed to creating our alignments. All right, so moving on, we are at the next step of the design process, which is to create the horizontal alignment. But before we do that, of course, we need to have our codes set up so that it can be checking our design for us. So to do that, just type design criteria editor and press enter. So by default, you have the AutoCAD Civil3D 2011 roadway design standard. All right, so you can modify this into your country's codes and then save it into Civil3D. Okay, that's the simple thing to do. So look at under units, we have metric, whatever. So this is just a normal unit. Okay, if you are using metric system, which is for Nigeria, we're using metric system. So you leave all these ones by default here. So unless there's a need to change them, but here is where you make the changes. So in the minimum radius table, okay, it might be different for your country. So this is where you just adjust it. All these things are editable. So you can edit all these files, all these things, and then save it. So let's look at this first one now. Okay, let me open our manual, the Federal Ministry of Works and Highway Standard Manual. Okay, this is it. This is how it looks like. This is the first page. okay, let me go to page 64. That's where what I'm looking for is. Page 64 contains the minimum radius table. Okay, as you can see, for a design speed of 50, now it looks like we don't have design speed of anything below 50. Okay, so on this table, but actually we do, because this is the formula here, right here, for calculating the minimum radius. So it is, you can look at this later. Okay, let me not describe it. So if this table is what you are constrained to work with based on your country's code, you can program it in that interface that we just saw. Okay, here is it. Let's say maximum for a maximum super elevation of 4%. Okay, all this was for 4% at 50 design speed of 50. We have the radius to be 86. So if you look at here, for 50, it's 86. It's almost the same. I mean, it's the same for H2, just that in H2 we have lesser design speed. So for instance, if I want to have these ones removed, so I can just click on them and then click this button, all right, then remove them. So I'm left with from 50 up to 100. Is that what I have here? Yes, from 50 up to 100. So yeah, so this one is already, I'm beginning to customize already. So let's say my own is up to 120. All you need to do is click here and then add 120. Okay, then I said maybe if I've calculated it, maybe 700, the minimum radius there, I put it. So once you do that for your own country's code, calculate everything. All right, if your own formula happens to be different from this one here, you can calculate everything and then impute them for a maximum super elevation of 4%. Then for a maximum super elevation of 6%, you do that. Once you change everything, while you are changing it, you can change the name here. Okay, let's say I change the name here. You just double click. I change the name. Instead of H2, I call it FFMWH, Federal Ministry of Work and Housing, Highway Manual. Then it's 2013 hours, so I'll just edit it as 2013 and press enter. So can you see I've just saved it? So I do that for all assuming there is different. Okay, so when you are done with that, you go to super elevation. Then if there is need to change this one, these are formulas. If there is need to change the formulas, you change them. This is the attainment method for super elevation. Okay, so when you go to the super elevation tables, okay, as you can also change them. Once you expand it all, you can change these things if they are different from your own country's code. It's quite you will spend a lot of time, some time doing this, but once you do that, of course, you're going to save it and then use it for future designs. So minimum K table, like for our K table, it's almost the same thing, of course, with H2. So but if there's any difference with your country's own, you just adjust it here, and then when you are done, look at this button right here. It says save as. So when you click on it as save as, then you browse to somewhere in your file where you want to save it to, and then save the file. So let me cancel. So I'm not saving anything because I already have it done. Okay, I just need to import mine while I'm designing. Okay, so let's quickly go to design our alignment. So before we do that, remember I'm going to be working on the center line, okay, only. So remember we created a group for our center line. So let me select that group and isolate it. Okay, let me select my center line and then isolate it. Great, I've just isolated my center line, so I'm going to have less disturbance while designing my alignment. So let's go to design the alignment. So you find that on the home tab, and then you go to alignment. Under alignment, you select create alignment creation tool. Once you click on that, it opens up this dialog box for you. So you have to name your alignment. Let's say you call it road 1. Okay, already we have this account, this thing naming it for us. Okay, I believe if you open your own, what you will see here is alignment 1. All right, because I've worked on Civil3D before, it can use information that you have used before. Okay, so let's say we're going to name this road 1. You can name it manually, or you can have Civil3D set up a template with Civil3D, just like was here before. Let me just show you. On this template, I can just call it to name it road next counter. I added this as next counter. So, and the counter is starting from 1 and increasing by 1 always. So if I said okay, so you will see it's going to name this alignment road 1. Okay, and then if the next alignment I'm going to design is going to be road 2. Okay, it will automatically be naming it, so I don't need to feed any name on this place again. So that's the good thing Civil3D allows you to do, just automates the process. So let's go down. Now we have the general tab. Okay, we can save it to a site, but we don't have a site for now. So, and then the style is a proposed alignment. These are default styles that are available for you. Okay, you can always create your own style by coming here and do create. This style simply shows you how your alignment will look. Okay, the colors for the lines and the the styles of the lines, the labeling and everything. Okay, here comes the labeling. So in this case, I just want to label the major and minor stations. Okay, and that's good. So now let's go to our design criteria. Now by default, we have our design speed to be 100 km/h, which is exactly what we have derived for our design. But in case there's a need to change, you just highlight it and then change it. Let's say 80. Okay, once you have 80, that is if that's your design speed. But let's go back to 100 because that's our design speed. Or unless I forget, here where we have description, you can describe that alignment. Assuming of course you are working with different engineers or even with yourself. Sometimes you forget what the alignment was for, so you can just describe just anything that you wish to add to the naming. Alright, so now right under here you have to check use criteria based design. Now right under it you will see the ellipse button for you to go and import your design codes. Remember I showed you how to save it. So if you have customized your own design code and saved it, find it where it is. So let me look for where I've saved mine. So I'll go to documents and then I'll just quickly rush through where I have saved it, and here is where I've saved my own, the standards for Nigeria. So once I open that up, you would see everything is customized to Federal Ministry of Works. Alright, Highway Manual 2013. So you can see now based on our design, we have maximum elevation of super elevation of 6%, and then the transition lane, it is 2 lanes. Okay, and then the attainment method is crowned. Okay, so it's a crown road. You know what crown means? We're having a crossed slope. Okay, the road is not, we have a camber. Yeah, so now I don't want to use a design check set. Let me uncheck that. Okay, so and then let's have an okay. So it brings up this ribbon for you. As you can see, this is alignment for road 1. So if we zoom into where we intend to start, all right, we have all these tools allowing us to manipulate and insert our alignments. And alignment is just made up of straight lines and curves. So from here we can just choose. Let me show you. Let me just quickly use the best method I use to design this. I first of all look at this alignment. Of course I've studied this alignment and I've seen that okay, from here we have a straight line, and then we'll have a curve here, then we'll have a straight line maybe going all the way up until somewhere here, and then we have a curve, then we'll have a straight line, and somehow as if we're going to have some dancing profile here, but it cannot dance too much because our design code will show us an error if we are below. So let me just quickly start. Okay, I'll just pick up a line here and then start from the beginning. Okay, once I use that, I find a straight section and end it. Okay, like up to here I believe my alignment is straight, so I press enter. Okay, we are not done of course, so we have to find another straight section. Okay, from here, let's say from here. Okay, sorry I did that wrongly, let me pick it up again. So from here let's see. Good. So going all the way to here, let's say it's a straight section. Okay, let me zoom in. Yeah, that's a straight section. Let me just enter. Okay, so as you can see, I need to add a curve here, so I can use the fillet command. I can find that here. All right, you open up, you select free curve fillet between two entities with radius. So let's put it here. We select the first alignment and then select the second alignment. It is less than 180, okay, the angle, okay, and then select one. I'm sorry, let's put a radius. Remember, our minimum radius was 437 based on our design speed. So let me use 450 here, for instance. Wow, 450 is almost cool. Okay, yeah, it's almost cool. It's almost going through our points. Of course, these points are not design points. These are proposed center line, but we are designing it, so it's not going to pass through all the points. Okay, so it looks good. It looks good. If there's any need to adjust it, for instance, let's say backward this way, I can see that we can move it backward. So we can drag it. You hold this circle and then draw it backwards. So in that case, it will increase the curve radius. If you want to see what radius you have just done by what you have dragged, you can go to add a label. Okay, and the label I'm adding is an alignment here. So I can label a single segment. Let me just add a label here immediately. Okay, let me close that. Let me stretch that out. Okay, as you can see, the radius here is 490. Okay, so it's well above our design code. Okay, so if it was below, it will alert us. Let me just make it below and then show you how it will show an error. Okay, let's say we push it upward here. Can you see there is a warning sign here? So what does that warning sign say? Minimum radius is violated. So the current radius is 344 and the minimum radius should be 437. As you can see, the radius here is 344, which is below our standard. So we have to move it back in order for that error, that warning symbol to go, and our road is correctly designed. Okay, so yeah, so now we are back to 488 somehow. If you want to use a round figure radius, you can just do that by opening up this tab here. Okay, you will see the curves here. This is the curve. Okay, this is the radius here. You can manually add it here. You have to first, okay, you can manually add it as it opens up. Let's say we type 500, that's what we want to use. Enter. As you can see here, it's updated here. So you can now close this thing back. Okay, so yeah, we'll do the same for the remaining part of the alignment. Okay, let me just do one more. Okay, here we add another straight line. Let's say we find a straight line from here. Okay, let's say up to here looks straight. Okay, up to here looks straight. You must not even click on any line. You can just stop halfway. It looks like it's passing through somehow. I'm not going to go into all these details, so I'm just doing this just to show you, to make you appreciate the process. Okay, because you don't just draw it anyhow. Okay, you have to, since we are working with a proposed alignment, we can now try to match it, okay, with it. But if we have the liberty to just design when we have a large space of data, we can just choose randomly where we want to pass. But of course, it has to be with a proper information. So now let's go again and add curves. Okay, now I'm going to use true point, not radius this time, so that it will be more dynamic. Okay, if I click here, then click this place, the second one. So I have the liberty to just be playing around with it and then find the best fit and then drop it. Once I do that, I press enter. Alright, so you can see I have put a curve here. Let me also add a label, okay, to this place. I can add multiple label at a time, okay, but it's because I've not designed the entire thing. If I use multiple segments, but let me just use single segment for now, and then add a label here. Okay, then you can see the radius is 438. Wow, that's a little bit above the design the limit. Okay, If I want to add that, I don't like it, maybe I'll still go back to that conceptual ribbon and then look at it here. So let me add it. I need to, okay, if it's not opening up for any reason, you have to unlock it. Okay, once you unlock it, it allows you to now edit it. Okay, so let's say I want to use 450 instead of that, just to use something of round figure. Great, so you can see it's 450 now. Okay, I can make my my radius, you know, a round figure. So that's what we keep on doing until the end of this alignment. Let me do that quickly and then we proceed. Alright, so I've completed that for all these alignments. Okay, you can do that on your own. Okay, you can see that there is no error, everything is moving fine and everything is, you know, coming close to my existing center line. Alright, so the next thing is to just close this. Okay, once I have closed this, I can now create the alignment for the intersecting road. Okay, and sorry, I forgot to mention that this road is 60 kilometers per hour, the design speed. Okay, so because you can see there is more sharp curve here. If it was 100 kilometers per hour, you can't have this kind of sharp curve. How do I know it's a sharp curve? Because I've had experience designing it. Okay, so let's design the next alignment. So we go back to our alignment, okay, and click on alignment creation tool again. So remember our good old template. It is going to save it as row 2 this time around because the next counter is 2. If you look at it here, you will even see that it's also 2 here. But I'm not going to all these things, you know, it's just to show you how Civil3D automates things. Alright, so let's go and put everything just as we selected before. Then go to design criteria. Now this time around I have my design speed to be 60 kilometers per hour. So let me use criteria based design. Then I'll find where it is. Okay, let me browse to where my codes are. Okay, I just selected it. Okay, once I select it, it allows me to use the maximum spallation. In this case, the maximum spallation is 4%, you know, for 60 kilometers per hour. You can check that in the design specification. So I'll uncheck this, so and press OK. The same thing as I did in the previous one. I'll just look for a straight section and draw a line. Okay, I'm supposed to start from this intersection, but let me start here. I'll extend it later. Okay, I'll just start here. Okay, and then find the straight section. I think the straight section is going to end somewhere here. Then I press enter. Then find another straight section. Okay, and then let's say from here. It doesn't. I'm making sure just to draw something that passes through at least 3 points. Okay, or 2. So yeah, so then I will have to put in a curve, fillet curve, and then add radius. Okay, it's less than 180, and then we can use a radius of, let's say 400 is too much, so let's say 200. Okay, that works. But is it within the design code? Yes, because we don't have an error. Okay, how do we know what is the minimum radius for a road of 60 kilometers per hour? You can find that on your design criteria editor. Okay, you can just quickly check on that. Oh, it's still showing metric this row. So let's quickly bring in our own here. Where is this? Okay, if you look at it on the minimum radius table for a 60 kilometers per hour, the minimum radius is 135. So as you can see, we are within the design you know, specification. So let me just do that for another section. Let me see, I think I have a straight section from here to here. Okay, somewhere here. Okay, I'm not going to, you know, be meticulously doing this thing. Well, you know, it looks like a tedious process, but I'm telling you, once you do pass through all this process, you don't have to do much adjustments. You know, there's a process of you using you know, tangent with curve. This is a popular way, but I'm not going to use it because it's only when you have your PIs, your point of intersection, you know, given to you by the surveyors. You know, there are some surveyors that will do a standard work and propose the alignment for a strong, I mean, when we have a real surveyor, you know, taking the data, he will even be proposing an alignment, so making the work easier for the engineer. So, but when we have just surveyors that takes the point randomly, you would have to do everything by yourself in the design. So, and that is luckily what I'm teaching you, because I do this constantly every day in my design processes. All right, so let me now add the curve. All right, so you add a curve between these two. Okay, less than 180. Let's still put 200. Okay, 200 seems to be working for us so far, but this one seems to need an adjustment. We can push it back. Okay. As always, if you want to see the radius you have just done now, it won't show you here. You have to add a label for it. Okay, once you add a label, you can be able to see it, or you can open up this wizard here, and then you will see that radius. I think the first one was 200, the second one is 224 point something. If you want to make it a round figure, as usual, just unlock it, and then let's make it, instead of 224, let's make it 225, just not to have any decimal point. Okay, so once you do that, you can do that for the rest of the road. But in order to shorten this class, okay, I will not do that for the remaining. I'll just leave it there. So back to this place where it's supposed to intersect. You remember I told you we have to make this road intersect, so I just have to stretch this. Okay, I pick this up and then stretch it, and making sure that I'm in the same line, okay, with okay, if that is not working, okay, there's a way I normally used to do it. I'll just draw a line, a polyline, just a PL, and then click from here, and then allow it to intersect, so I'm to move, and then drop it somewhere, so that I'll have something to snap. Okay, once I drag my alignment this time around, I can snap to where these two intersect. Great. So then I can delete my polyline. Okay, yeah, so I have make sure you have stretch it to intersect without interfering with the alignment. So great, that is it. So we can now move on to creating our profiles if we are satisfied with the alignments and completed everything. All right, so let's close this. Okay, now we have to go to creating our profile. All right, so how to do that? Just click any of the alignment, and then this contextual ribbon changes, and then you will find surface profile here. So just click on surface profile. Okay, and then you will see that you have the alignment road 1, which is this very road, and then you have to select a surface, which is the existing ground surface, and then add it, and then it gives it a name. This name is not so good. You can actually, you know, adjust this naming system, or however it's naming it. I don't like it. Normally I used to create this thing template, okay, how it will name this thing. Okay, this class cannot cover that. You can find a way to do that yourself. Okay, so we draw in profile. Okay, all right, so we have this road 1, the alignments, you know, all these things. Let's leave it by default. What this thing simply means, all this window, I mean, allows you to modify how the profile will look before you create it. Okay, normally for me, I'd have to just create it, okay, and then adjust anything I don't like. But let me just walk you through what you can do here. So you can give it a name. Okay, this is using a template here. Okay, so we can just call it road. If we don't want to use that template, road 1 profile view. Okay, then add a description if you want to. Then the style, this controls how the profile is going to look. so we are using a profile view style. We can actually create our own. Yeah, so you go to station. Okay, you see the station. This is showing you the length of the road, so you want to start from the beginning to the end. Of course, that's what you want. But if you want to have a specified range, you can actually choose this and then put a range, but usually we want it for the entire length. So the profile view height, okay, we leave it at automatic. Then the display option, these are things that you can always modify later when you create the profile. If you see that you have not found something that you are supposed to see, okay, you can always edit. So let me just go down and then create this profile. Leave everything by default, okay? So because the default is exactly what you need basically. So now we are going to create the profile. We are going to find somewhere on our workspace, not go too far, but don't be too close so that you don't overlap on your alignment. Okay, so let's find somewhere here because it's going to create it to the top right. So we'll just click here and then you'll find it here. So if you can see, the red line is showing us our existing ground profile. Okay, so now this grid, this vertical grid looks quite noisy. Okay, it's too bold and it is looking too, too bold. So we can actually adjust how it looks like. You can click on it and then on this ribbon here you can choose profile view properties. Okay, once you choose that, it opens up this profile view properties. You can choose how you want it to look like. Okay, so remember the name we gave it, road 1 profile view. All right, that's why you see it here. So the stations, you can choose okay, these are the bands. Oh, not here. Let's use profile view style. Okay, profile view style. Okay, select. Oh, I mean, no, forget about that. Let's just right click and then go to edit profile view style. Okay, it brings you this. So it allows you to select the grid. You can add from the information. This is the profile view style. Okay, you can customize everything here. This vertical exaggeration shows you that this profile has been exaggerated in the vertical direction by ×10, which is always good for you to exaggerate your vertical profile by 10. Okay, it allows you to see the undulating nature of the road properly. Because if you put it by 1, the road will be relatively flat. Let me just do that and show you. Everything will just look flat, but that's not what you want. You want it to be exaggerated by 10 so that you can see clearly. Now on the grid, there are so many options here. Okay, I'm not going to go through everything. Okay, but what is important here is in the horizontal axis. Okay, mine is good. It's at 25% interval. So my change is at 25. Sorry, not percent, 25 meters. Okay, so I'm working on a change of intervals of 25 meters. That's what you have here. Then the intervals, as in the intervals, is 12.5. So the major stations is 25 and the intervals is 12.5. That's exactly what I need. So you can see that here already. It happens to be here by default because I've been working with the file. Okay, so if it's not so, you can just adjust it to whatever you use. Some people use major stations 20 meters intervals, so you can change that. Okay, let's change that to 20 meters so you appreciate the class better. So you go back there to the profile view style. Let's change it to 20 meters, 20 meters interval, 20 meters intervals, and then 10 meters. So 20 meters major station, and then the 10 meters minor station, of course. Let's apply that. Okay, as you can see, it changes here automatically at 20 meters intervals. So that's great. All right, so let's proceed to creating the design profile. This is our existing ground profile. Let's create the design profile. So let's go on to profiles, and then profile creation tools. So you select anywhere on the grid, and then it allows you to name. It opens up this ribbon allowing you to name your profile. Let's say rule 1 design profile. Okay, again, you can create a template that allows you to name it the way you want. So let's proceed to the and select the profile style. Okay, and also we can select the label styles. Okay, let's just leave it to the default here. The design profile, complete label set here. Then on the design criteria, again you go back to import your design codes. Now if I wish, I would have just saved that design code here, so that Civil3D always sends you to a particular folder by default. So if I bring that my code here, next time I don't have to start browsing through. Okay, I don't have to start browsing through to find where I've kept it. Okay, that's the importance. So let me uncheck this and press OK. So it opens up that ribbon, just like the alignment. You can create alignment, create it with straight. You find a place that is relatively straight, and then draw a straight line. Now if I were to design this road, of course you have to study the profile first, and then after studying this profile, I find out that I can just go straight from here all the way to here, and then have a curve that will take me to this hill, and then I reach this crest here, and then I have a high point, PI here, and then maybe go down a little, or no, or just still keep going high. Now look at this roof. This place is quite close. There's no allowance here. I can adjust that on my profile view style. Okay, right click and then go to profile view style. Okay, once it opens up, I go to my grid. Okay, and then above maximum elevation, let me have like 2 meters above that, and apply. Okay, let me make it 5 more. Okay, as you can see, I have more room here, so that I will it will not prevent me from adding a PI higher than that. So let's now proceed. I'm going to use let me do my curve settings. Okay, I'm using a circular curve. Okay, some use parabolic curves. Parabolic curves is ideal. Okay, but circular curves is easier to construct. I think I've made a post regarding that on my LinkedIn profile. So if you're not following me on LinkedIn yet, you can kindly do that, so you can find me when I make posts or comments regarding road design. So let me put a default radius of 1000. Okay, both for crest and sag. Okay, once you do that, you can now select draw tangent with curves. Okay, so now assuming I want to start exactly from here, then I pick it up. Then as I told you, if it's were me, I would just go straight, okay, all the way, and then level all this place, then find somewhere here and have my PI. Okay, and then I'll go up the hill. Okay, and then drop my PI somewhere here, and then keep going up, probably drop my PI somewhere here. Now I have a large field. Okay, that may not be economical, but I can adjust this till later. So once I'm done, I press enter. I basically put my proposed profile, but I can always adjust it. Like this curve is of course too small. Okay, then you can just drag this and then increase it. Okay, or you can just use this button here and then increase it up to here. Okay, yeah, now this place looks quite small. Okay, all right. So for the purpose of this class, I'm not going to go deep into all these things, but you can adjust this thing continually, just like you saw me was doing on my profile. Okay, and then until you find a profile that is suitable for you. Okay, like here now I have some cuts here, I'll be having some fill here. then I'll be having some just like that. You can just keep adjusting this until you get what you want. So for the purpose of the class, let me just stop here, editing the thing here. Okay, so let me close this. So I'm done with this road 1. Let's go to road 2. So the same thing, you click on this and then you create surface profile. Okay, then you just add the surface and then draw in profile view. When you draw in profile view, you go to leave everything by default here, just like the previous time, then create profile view. All right, so once you've done that, you can now just click it, find it somewhere here. Okay, this is the existing ground profile for the road 2. So we go to design the road. So profile creation tools, we select it. Okay, and then populate everything here. Let's give it a name, road 2 design profile. Okay, then we use our criteria based design. Again, we have to import it. Okay, let's go to where I've saved it, then open it up. Okay, so then I press OK. Again, if I see this profile now, after studying this profile, I find out that I can just have a straight up from here up to here and then down to here. So let me click that. From here I have here and then down to here. Enter. That's all. Okay. Oh, I do not use tangent with curve, but no worries, you can always add the curve by just coming down here and then find free vertical curve. You know, you can just do that. You click this alignment, click alignment, and then specify the radius. Let's say 1000. Enter. Great, so it has given us a curve, but still I don't like the 1000 is not enough for me. I can just drag, you know, up to here, and then like previously I told you, you can just adjust it to wherever, however suits you best, but the code will be showing you whenever it is below standard. Okay, whenever it's below standard. All right, so that is it. That's how you create your design profile. All right, so let's move on. All right, so once you are done with everything, you just close this. The next thing we are doing is to create our intersection. Now let me quickly show you something on the profile. You remember that you realize that these two roads are intersecting, right? They are intersecting, they are not independent of one another. So we designed these ones separately, but that does not mean that how are you sure that the level here is the same as the level where this road is intersecting? Okay, let's look at it. These roads are intersecting at about chainage 3 plus 420 on road 1. Road 2 is intersecting road 1 at chainage 3 420. So let's find that where it is. 3 420. Okay, 3 420. You can see. All right, you don't have to do it manually and be checking it. There's a way you can bring in that road 2 profile here and see how it is looking. So let's just do that. If you click on this grid anywhere, you'll find somewhere up here that shows you superimpose profile. Then go to road 2 and then click the design profile. Okay, and then come back to this place and then click anywhere on the grid. It opens up this ribbon and allows you to select whatever you want to select here. I won't go through all these things, but I just want, if you just want to have only some sections shown, but I want everything shown, so let me just press apply. Okay, and press OK. So now you can see how road 2 is on road 1. Okay, obviously the levels are different. See where this one is intersecting. So these two levels have to be married. These two blue lines, this is where the starting point is. So this one has to marry with this. But how do I do that? I cannot just drag it. I have to create an intersection. So watch this closely. As you have seen this, by the time I create an intersection, these two will join. This one has to go there. Since this one is the one intersecting, it has to go down to meet this road. And so if I want to adjust it up back, I have to adjust road 1 up, and then road 2 automatically follows. Alright, so let me go and create an intersection. So I find intersection here on the home tab, and then click on intersection, create intersection. So I find where it is intersecting, and then click. Remember, this is one of the special features of this design, okay, because it's not quite an easy thing. Not everyone covers it, you know. I'm taking my time to do this because I love you all, and I want everyone to, you know, be proficient in what you're doing. All right, so here I'll just create an intersection. I don't need to create all these offset parameters. I will not go through all the reason why, but just follow me, okay? And then automatically all these things are unchecked. So I just want to create an intersection. So I can name the intersection. Civil3D is just giving me a template whereby it will just name it intersection 1, and then if I'm creating another intersection, it will name it intersection 2. Okay, so if I want to add a description, I can add it here. If I want to select a marker style, but I'm going to leave it at default here. So you can always create any of your, you know, default views if you want, but basically leave everything by default. And this road is an intersection whereby the primary road, which is the main road that is traveled at 100 km/h, is crowned. Okay, while the other one will just be joining it without being crowned at that intersection. Okay, but if both of them were roads that are driven at 100 km/h together, I would select this option. All roads will be crowned, so it will be crowned at the center. So, but for now, since the primary road is at a higher speed, I'm going to select this one. So let me create an intersection. So once I create this intersection, watch what happens. Okay, automatically it names it for me. Okay, it should be 1 here, but never mind. Okay, so this is the intersection. Let's go back to our profile and see what happens. Ta-da! You see, this profile has automatically come to marry the intersecting where it is intersecting. So anytime I make an adjustment, both of them will go up. Let's say I want to adjust this one upwards. Okay, let me adjust this profile upwards. See what happens. Great, you see this one is following it. So it has to be intersecting in both alignment and profile. So that is the importance of creating an intersection. Wow, I'm teaching you all these things for free. Yep. So I spent a lot of time learning this myself. When I was doing it, I was always worried. There was a time I was doing it manually even. Of course, by the way, I have designed roads on AutoCAD, just normal AutoCAD without Civil3D. I do that always. It's quite smooth, it's quite sweet, but it's not automated. That's where the issue is. When you are doing revisions, you will suffer. But on Civil3D, you can make revisions fast. You can design a large network of roads fast. That's why Civil3D is powerful. And besides, it's also BIM compliant. So, you know, I'm a BIM enthusiast, right? So I have to upgrade. I had to upgrade a long time to Civil3D. So that is it here. Okay, we are creating an intersection. The next thing is to create our offset alignments. All right, remember our roadway is 7.3 meters. Okay, so that means 3.65 to the left, 3.65 to the right. So let's create that offset alignment. So where do you find that? You find that here in alignment. Under alignment, you see create offset alignment. Once you do select that, you click the alignment you want to create an offset. Okay, and then it opens up this. Okay, you can name the offset alignment. Here it is going to use this template. I just want you to use a template because since we are going to be creating an alignment both to the left and to the right, so automatically to be naming it left and right for us using this side here that you are seeing. So this is a template that automatically knows that okay, this is the left side, so it names it to the left, and then it names the other one to the right. So make sure you are if you want to start from the beginning to the end to create the offsets, yeah, you can choose that here. Okay, just leave that both of them checked. Okay, now we are creating you can create multiple alignments, offset alignment to the left and multiple to the right, but for now we just have one offset alignment to the left, one to the right. So here, remember our lane is 3.65, so I'm going to put 3.65 here, and then also here 3.65. all right, so we can add a site, we can have offset styles, and then we can choose a level. Now I don't put levels when I'm doing offset alignment, because already there are labels in the main alignment. So let's go to the widening criteria. Okay, now I don't need any widening, so I'm not going to add that, and of course no design check for that. So I will create an offset profile for sure. So because I have a profile on this design profile on this center line, so I'm going to be using that very design profile. Okay, that road 1 design profile. Now, do I want to superimpose it to the road 2 view? Yeah, if I want to, so that it will show on that profile view. Okay, but I don't want to do that for now. So remember, our cross slope is 2.5%. okay, if you remember the review that we did. Okay, if you are using 2%, you can leave it at that for your own road, but for this road is 2.5%. So, and then the profile name, it will create an offset profile with this. Okay, and then slope it down by 2.5% to at 3.6 meters. Okay, and then it will name it, okay, using this template. Let's leave it like that. So let's use the profile style as existing, design profile. All right, so because it's a design profile, so let's press OK. Okay, once you do that, you can see that this is the offset alignment. Very beautiful. Okay, this is already looking as the road, proposed road. What does this offset alignment do? This offset alignment is dynamic. Okay, when you change the center line, it also changes automatically. So let's say I change this to somewhere here, you can see it's moving together. Okay, if I drag it, if I drop it anywhere, okay, it will update. So let me go back by pressing Ctrl Z. Okay, and then I'm back. So that's the good thing about the offset alignment. So let's create offset alignment for the intersecting alignment. So let's create offset alignment. Create offset alignment. I click on this. So since it's the same thing, oh sorry, I'm creating connected alignment. I'm supposed to create offset alignment. Yeah, I click on this, and then it opens up again. So I'm going to allow everything to be the same. Okay, of course you can see 3.65 is already populated here for us. So everything, I'm going to leave it the same, because it was fielded before, and Civil3D is merciful enough to allow everything to be back in case I want to use the same things. Okay, so I'll just press OK, and then yeah, it has created it for us. All right, so the next thing I'm going to be creating is the connected alignment. Okay, why is this important? Because as you can see, this is an intersection, so you have to drive through a curve when you are going to negotiate this intersection. Okay, you have to drive through a curve here, so you cannot do that with just the normal fillet command. You have to use that using connected alignment. So you find that here under alignments, you go down to create connected alignment. Okay, you click the first offset and then the second offset of the intersecting road, then pick a side where it's going to be put, then you press enter. Okay, it opens up this window for you. It's a little bit different for 2023, you know, as opposed to 2018 and 19. Okay, if you're using 2022 and 2023, this platform here, it looks different, you know, where to find what to put, but it's the same thing, so don't worry. So here you can name it. Okay, give it a name, or allow Civil3D to just name it for you. Here we can just call it let's say left curb return. Okay, yeah, because a curb return. So let's see what we have here on the general tab. We can choose a site, but we don't have any site. So we have the alignment style to be proposed. And then the label side, I don't want a label, so good. I don't need labels because the labels are noisy. So on the design criteria, I'm not going to be using a criteria based design for this one, because it's going to be judging it as if you are driving at a long speed, at a speed when you are negotiating the intersection. Usually you are almost at zero when you come to the intersection before you now start driving. So you just need any curve that will allow you to turn. And usually, you consider a truck, okay, a large truck that is about 20 meters long. So when it's negotiating this corner, usually when you're using WB12 truck to design, it's about 20 meters long, so it needs about 11 meter radius here. So but for this course, we're going to be using like 15 meter curve radius. Where do we find that? All right, you can find that under parameters. Okay, so the curve radius is going to be, let's say, 15 in this case. Okay, so and then and the offsets, I don't want any offsets right in. If you're using 2018, you won't find this thing, but if you're using 2023, you'll find all these things here. So I don't want any offset to the left or to the right. You can even press preview. Okay, so it says no. So we have to select a circular fillet, not spiral curve. So we need a circular fillet. So let's preview that. Good, you can see how it is going to be, okay, when it is done. So I think this is good, and it's going to be overlapping by 25 meters. Okay, no problem. You can adjust that if you wish. So then for connected profile, definitely is going to create a connected profile. So in this case, as you can see, the cross slope is 2.5%, which is good. If you have it as 2.0%, you can change it to 2.5% because that's what we are using for our design. So, and the alignment name is going to use a profile name template. Okay, let's call it let's see what that template is saying. Okay, starting from 1. Okay, for now let's just have it like that. Okay, so again, we are just using a profile style as design profile. Then the profile curve type, okay, is going to be either parabola or circular. I prefer circular because, as I told you, it's easy to construct. And then the radius, I can just use, let's say 1000, or let's say 500 for this. Okay, let's say okay. Now great, so we have created that our alignment. So I used the style design profile, that's why it's looking like my center line, but actually I should have used offset profile, but that's not a problem. Okay, then let's do for the other one. We go to the alignment and then create connected alignment. We select the first and then the second, and then find the side and then press enter. We are also going to use 15 in this time. So let's just quickly go to, everything remains the same. Let's just, okay, let's call it, did we call the other one left curve return? Okay, I can open here. So we call it right curve return, right? So let's call this one left curve return. So let's leave everything the same. It will almost be the same. In fact, everything will be the same because we have Civil3D is merciful for us, so that we will not just be doing it again. So the connected profile, everything just allows us to use that template that was there before. Now I'm going to just use what I could have just used all this layout profile, let's say layout, okay, and then everything okay the same. All right, you can see, okay, still green. You can make it white, you can change the color to white. You can just right click on this and then go to alignment properties. Okay, once you have this alignment properties open, you can select, okay, sorry, you can select how it will look. Let's call it intersection basic. Okay, apply. That gives us that white one. I like the white. Okay, and also this one, you can change it for this one, alignment properties. All right, so you can change it to intersection basic. Press okay. All right, so that's that by the way. Okay, so let's say we're okay with this. So we can now move on to the next thing. So look at our road, it's looking fine, is it not? All right, so the next thing we are going to do is on the design steps is to create our road assembly. Okay, so if you remember, this is how we want the typical cross section to look like. All right, so we'll try to model this into Civil3D so that we can create a corridor from there. So let's go to assembly under the home tab and create design and create assembly. All right, so if you look here, you can name the assembly or use the template that Civil3D provides for you. But because we are going to have so many assembly, I'll show you why shortly. Let's call this full assembly, the one that will have all the parameters together. So, and then we are going to give it a type undivided crown road, and then we'll choose the assembly style to be basic, and the code set, let's use view edit. I like it for some reason, but I will have my style, which you can also create yours by using this create new here, but we're not going to that. So let's press OK. So you choose somewhere within your drawing, anywhere that you can locate later. Okay, I will choose to do it close to my start of alignment, somewhere to the right of it. Alright, so then I'll click there, and then Civil3D will zoom into the center line for me. This is the center line, the baseline for creating the alignment. Alright, so creating the assembly. Now let's bring in our tool palettes. You click on this place and open up your tool palettes. So we're going to start from lanes. Okay, we'll choose lane super elevation AOR. So it brings up this properties window, allowing you to put in all the this thing. Remember in the cross section we have a wearing cost 50 mm, binder 100, base cost 150, sub base 300, and then subgrade will be designing by cut and fill. So let's start. We are going to model to the right first. So let's model to the right. Then our width, if you remember, is 3.65. Okay, let's look at the drawing. 3.65, and then our shoulder 2.75. Alright, so our width is 3.65. Then our cross slope is 2.5%. Alright, so our pavement depth is the first depth is 50 mm, which is 0.05 meters. The second one is 100 mm, the bender, which is 0.1. The base depth is 0.15, and then the sub base is 0.3. Great, so leave the every other thing as it is. So let's click on this. So as you can see, it brings it up for us here. So the next thing we are going to do is to model the shoulder. So if you see, you can see shoulder. Okay, yeah, here is shoulder. So you choose shoulder extend all. Okay, that's the option you can choose. There are many, but for now we're using shoulder extend all. Okay, so let's click we're going to extend, but before that, of course, we are going to adjust our parameters. So shoulder width, the side is right, the shoulder width is 2.75 from our proposed cross section. Okay, so away from crown, let's have it 2.5% here, and then the daylight slope, remember it was 2:1 in the cross section, 2:1, and then we have the daylight width. All these things, leave it to as it is. So we have this 2.5%. Okay, I forgot, I think in the shoulder is 3%. Okay, yeah, shoulder 3%, so let's just make it 3% here. 3% here, shoulder base slope 3% too. Alright, so where do we go? What is remaining? Nothing. So let's extend our shoulder. Now, actually we don't have asphalt, okay, on the shoulder, but I'm still going to just put asphalt. I don't want to go into all those complicated things. If I don't want asphalt, I can just make here 0, okay, because normally in Nigeria here we used to do surface dressing, just surface dressing on our shoulders, because it's not a travel way. Okay, it's just a service lane, something. I mean, it's just a temporary area for maybe when your vehicle is broken down, you can just park by that side. and also of course it's a good hypotenuse for the highway. So let's click on this node here, and then it extends our shoulder. Okay, it seems that there was something out of place here. It should be 150, but nothing spoiled. You can click on it, right click, and then go to sub-assembly properties, and then here it was supposed to be 15, so let's make it 5. Add 5 and then press OK. So as you can see, there's still some things that's out of place. Okay, maybe it was when I was creating this one. We have page 1, page 2, page 3. Okay, let me adjust it again. Sub-assembly properties. If it doesn't look as you want to, you can always be adjusting it. Okay, the first depth is 0.05. Yeah, that's a mistake. The second depth is 0.1, and then the third one 150, and thereabout. Okay, great. So you can see it matches close. Very good. So the next thing is to add our daylight. So we use daylight general. So you can adjust all these parameters, but I don't want to go into all these things, or else I will bore you. But you need to have it to be at slope limit to be 2:1. So, but I'll just put it there for now. This class is already longer than I wanted it to be. So just click on this. Okay, you have your daylight. Of course, it's to the right. Okay, it's to the right here, right here, as you can see. So once I've done that, okay, I can just close everything. I've modeled towards the right. I don't need to model the left also. Okay, I can just mirror it. So what I just do, I highlight everything and then click on mirror, and then click my middle baseline. So it mirrors everything to the left. So very great. This is my first assembly, and it's called full assembly. If I go to my prospector tab and go to assemblies, I can find that full assembly here. All right. So great. So I can now create my corridor. But before I do that, I would need some assemblies. I'm going to just create it right away, and I'll show you where it will be used. So I need half assembly to the left, half assembly to the right. So I can do that by modeling the whole thing again, or by just simply copying this assembly, copy it downwards. As I'm copying it downwards, watch closely here. You see in the assembly, it names it assembly full assembly 2, but I'm going to name it, give it another name as left half assembly. Okay, and then I press OK. It left because I'm going to delete all the ones that are to the right. I'll click all the links to the right and delete them. Great. So I have a left half assembly. All right. So what do? I also have to create a right half assembly. Copy and then create. I'll delete all the ones this way. Okay. I'll delete everything to the right. Okay, one after the other. So sorry, everything to the left, so I have only the right. So I will rename it to right half assembly. Right half assembly. Great. So I have half assembly to the left and to the right. So of course I can move that if I don't want that to be here. Let it just be somewhere here. So I'm going to create curb returns assembly. That one is a little bit tricky. Just follow me, and since this is a video, you can always watch it back again. So I'm going to I'm going to create assembly. This again, create assembly. I'm going to call it left curb return. Okay, and everything remains the same. Okay, and then I'll click on it. It zooms in for me. Okay, so I open my two palettes again, and then I go to lanes and then model lanes per elevation. Now this time, as I'm walking to the right, I'm actually walking towards the left. Okay, because you'll see that in a moment. So I'm walking to the right, and my lane is 3.65 meters. Okay, and then my cross slope is, now here I'm going to choose 2%. Okay, I'll show you why I do that. I want to not be minus 2%. So let's have all these things as we have it in the previous one. 0.1 here, 0.15 here, and then sub base there, this, and then everything. So let me click on that. Now, yeah, you see it's sloping towards this side. Oh, I put it 2%. It should be 2.5%. I can also adjust that here. Once I've created it, I can just adjust it here to 2.5. Okay, 0.5%. So I press OK. So now I'm going to be putting my shoulder to the left here. Okay, so my shoulder is going to be shoulder extend all, and then I'm going to be putting it to the left. Okay, just follow me. 2.75, and then the cross load is 3% for the shoulders. Okay, I believe it's 3%. Sorry, this is the shoulder. Okay, this is the shoulder, 3%. I forgot in the previous one. We are going to adjust that. Alright, so then the daylight slope is 2:1. Okay, and the depth, oh my god, Civil3D is not merciful in this case, so I have to put in everything again. So, and this one is 0.15. Alright, so there we go. Okay, so I think everything is fine. So I'm going to extend it to the left. So I'm going to select this. Okay, yeah, so it selects it to the left. Now, as you may notice, this thing looks big, the description, just because of the scale. Okay, if I choose that, if I reduce it to 1:200, okay, look, it looks nice, better. Okay, so let's add our daylight. Okay, go to daylight. We have our daylight general. Okay, and it's going to be to the left. Okay, great, it's to the left already. Now I'll just put that here. Alright, so that's my left curve return. I can model the same thing to the right. Okay, well, let me try copying this and then mirroring everything. Okay, I'll copy this. Okay, and then mirror this one. I'll mirror this one, mirror it, and then delete the one I've mirrored. Then select this one and this one, mirror it. Okay, and then delete the ones I have mirrored. So I've just created another one for the right. So I'm going to call it, rename it. I'm going to call it, let me delete this too, and then call it right curve return. I press OK. So these are the assemblies I need for my corridor. First of all, I'm going to create the corridor for the main, for road 1 and then road 2. Okay, so let me go to create corridor. I go to create corridor. Then we can have a template, but we need only one corridor actually, because every corridor will be the intersecting corridor will be tied to the main corridor. So I'm just going to call it main corridor. Simply. Alright, I'm not going to create another corridor. I'll just add region and baselines. You'll see that shortly. So I'm going to use just the basic style. I don't have unless I will create a new one. This controls how it looks. So and then it's going to be an alignment and profile. Then which alignment we need to do on road 1, and we are going to use the design profile. Oh, we are having two profiles here. What does this mean? Okay, this one is the superimposed profile that we did. Let me go back and show you that. Okay, you remember we had this superimposed profile. Actually, when we were done with it, we should have deleted it. So let me do that now. Once I delete it, okay, and go back to creating my corridor. Okay, I will not find it again. So let me call this main corridor, and then everything back, and then I'll choose road 1. So you see, it's just that design profile. So the assembly we're going to be using is a full assembly, and we are targeting to the existing glass surface. So once this is done, you click OK, and then you press OK to rebuild the corridor. Okay, so once you rebuild the corridor, you can watch and see how it looks. Okay, already we are looking at these places. We are going to be having cuts here. That's why it's in red color. These green are areas of fill, the red are areas of cut. Okay, automatically showing us what's happening already. So let's now move to adding corridor for this one. Now you don't have to create a new corridor for this one. You just add it as a baseline. All right, so we are going to add, just click on the corridor and press add baseline. So once you click on add baseline, now it asks you to name it, but we can just leave it to have this default name. It's going to be an alignment and profile, and what alignment is going to be row 2. You can do that by selecting the drop down, or if you don't know the name, if you have multiple alignments within this drawing already, you can just use this and then click on this and then press OK. Okay, once you have done that, you have to select a profile. Now the profile is going to be the road design profile. Alright, so you press OK. So we have created a baseline for this now. What does that allow us to do? It allows us to add a region. Still on the corridor being clicked, we are going to add a region, and if you hover around, you can see that the baseline has highlighted. So we are now going to click somewhere before the curb return, just anywhere, and then that will be a starting point, and then we are going to start from here, okay, and then go all the way to the last point of the alignment. Then which assembly I'm going to use? Still, we are going to use a full assembly. Press OK. Again, here we are going to be targeting to the existing ground surface. Let's leave that for now. Everything should remain the same in this case here. So, and then you have modded your corridor. Can you see that? Right, beautiful. You can see that it is one corridor. So if you click on it, all of them are tied to each other. So one thing is, we are going to split this corridor at this for the road 1. Okay, you have to split it. You split the region. You will see why I do that recently, shortly. So just double click and click again anywhere here. Okay, once you do that, it has split the corridor there. It's still highlighted, so click somewhere here. Okay, and then click the corridor, click to split again. So great, if you can see, we have split the corridor at here and this point. So we are going to change the corridor section, or the assembly section, for that region. So let's modify that region. Okay, we just use region properties and click on this place. Now you can see that we are using full assembly here. Here let's choose right half assembly. Okay, right half assembly, and press OK. Okay, you can see that it have deleted the left side and then using only just the right side, because that's what we have created. So the next thing is to add our curb return corridors. Okay, so let's quickly do that, but before we do that, we have to add them as baseline. Otherwise, when you want to add a region, you won't see anything to add. Let's say add region, you cannot see anything on this curb returns. So you have to first of all add it as a baseline. Okay, then you have to select the curb return. If you don't know the name, of course, an alignment and profile, you can just use this box here to click on it and then update the name. Then you press OK. All right. Okay. Oh, we should have named it the right curb return. Okay, I made a mistake, originally, so pardon me for that. So we are going to use this profile, so let's press OK. So I've created that curb return. So let me add another baseline. Okay, so I will select this one, so you can see this, the name. This one should be legitimately the left, and then this one the right. Okay, so I named it wrongly at that time, sorry. So okay, so let's go on. I've created now select the profile. I've created a baseline. Now if I want to add a region, you can see it will be highlighted in red. So that's what I'll quickly do now. I'll click on it and then start sweeping from the intersection of this to the intersection of this. Okay, great. So what assembly am I going to use? I'm going to use the right curb return. Okay, I'm going to use the right curb return. Okay. All right, so when we are to target, we are going to target the existing ground surface, and then for the width target, we are going to target the center line of this. Okay, let me just use okay, road 1. Well, okay, let me not just stop on myself on selecting. Let me just select road 1 and then add, select road 2 and then add. Okay, once you do that, then that will be the targets. And then for the, we have selected the targets for the horizontal, for the alignment. Let's also select the targets for the slope. Okay, for road 1 we are going to select the design profile. Okay, we are selecting targets for the elevations, so we press OK and then press OK. Great, you can see our corridor has been built around this curb return. Great, perfect. So let's quickly view that before we are done. Go to object viewer, then you go to, you can see, beautiful. So it's remaining the left one. Let's quickly create the left one. So again, we just go to add regions, you select here, you swipe from here and sweep up to the intersection here. Okay, all right, I should have my intersection snapping. What's happening? Okay, so I'm going to use the left curb return in this case. Okay, and then I'll be targeting to the existing ground surface. And then for my width targets, I'm going to be using the road 1 and the road 2 for my width targets. Okay, and then for my elevation targets, I'm going to be using road 1, the design profile, and then for road 2 I'll be also using the design profile. So I'll press OK and then press OK. So as you can see, it is targeting fine for me as well. So because this thing, so for some reasons I did not target it well, so I will just have to drag this to this. Okay. Oh, what's happening? Okay, it's not snapping for some reasons. Okay, normally I'll just right click and then go to, let's say, endpoint. Oh my god, but you understand what I'm trying to do. Okay, it's being slow for some reasons. That's what Civil3D, it requires a lot of your hard drive. Even with my fast laptop, I'm having issues. So let's go to endpoint. Great. Alright, so that is it. So you can see it has snapped very well. Let's now view it on the object viewer. Object viewer, if you can see clearly, you will see that my road have intersected properly. So great. So this is what we have just done. We have created the intersection. So it's simply one corridor, and then everything is all good. It's all good. So let's. All right. So since we are done with that, we can now close our tool palettes. All right. So you can see everything is smooth. The next thing on our design process is to create our corridor surface. Okay. How to do that? You can just click on the corridor, okay, and then click on corridor surfaces, or just go to corridor properties. Okay, under the properties you go to surfaces and you would find this interface right here. As you can see, there is no surface of the corridor, so you have to select a new surface, create corridor surface. So you can call this datum surface. We call it datum surface because it is the base, it is the datum line, okay, that we are going to be using. Okay, datum surface. All right. So, and then we have to add the links. We'll add links, and we are going to use the datum link. We'll add the link right under the datum surface. And then this under the overhang, okay, we are going to use the bottom links. All right, we are going to use the bottom links for the overhang corridor. So And once we do that, we're not going to add a break line. Okay, so that is fine. Now, but we need to set a boundary for our datum surface. Okay, so we have to use the corridor extents as boundary, which is the the daylight. Okay, so we can use the corridor extents. All right, so that's great. So we just apply. It will ask us to rebuild our corridor. Okay, and once we do that, don't mind all this. Okay, all right, so we close this and then check this. Now we have created a surface for our corridor. When you go, let me minimize all this. Go to surfaces. Okay, you will see that we have this datum surface created right here. So if we want to visualize this surface, we can just select it. Okay, and then go to object viewer. So you can see it have extracted the surface out of our corridor. So this is not our existing ground surface, this is our corridor surface right now. It's taking everything up to the you can see there is a very smooth line showing our proposed roadway, but the remaining by the side is the daylight, so showing the fields and also the cuts. Okay, in fact, let us drive through our road right now. Let's drive through. I think it's about time for us to drive on our road. Let's just do that by selecting the corridor and then click on drive. Okay, and then I want to use drive from the crown at the crown. So once I do that, can you see how beautiful this is? How beautiful this is. Let me drive it at at the speed of 100 km/h, because that is the speed of the road. Okay, let me select. Okay, I can just type that manually here. Okay, so let me just play. Right, can you see my road? How beautiful is that? Oh my god, this is a beautiful road. I love it. So that's what Civil3D can do. So as you can see, these are cut areas. Now you come to areas of fill. So you can see our proposed roadway. All right, the carriageway, and then the shoulder showing, and then the daylight. The daylight is showing you the cut and fill by the left and right. All right, so I can do that, but let me just close. Okay, and then close this view. All right, so we have created our corridor surface. That was the next thing, and then we have just done that. So the next thing on our list, on our procedure, is to compute materials. So let's go ahead and do that. Now, before you compute materials, you go to settings, and then you go to quantity takeoff materials, quantity takeoff criteria. So you expand it, and you would find cut and fill. There are material criteria that are available for you to use. Okay, but usually I like creating mine. Okay, I'll just right click on this and then create new. So let's create a new criteria. Now we are going to use we are going to add a new material here. Okay, let's call it, on the information tab, let's call it earthwork cut and fill. Okay, then let's go to material. Let's add a new material. We'll add a cut material, and what is the quantity type is cut. Okay, so under that we are going to be adding a surface. Okay, we are going to be adding number one, the EG surface, and then we are going to add secondly the datum surface. Okay, now what is cut material? Okay, cut material is everything that is below our EG surface. If you are going below our EG, so we are going to set below EG surface, and if it is above our datum surface, it's a cut material. So below, above, note that. Okay, so we're going to add a new material, and that material is going to be called fill material. So, and make sure that the quantity type is called fill. Okay, so these are back to this cut. We have the cut factor. So if you want to use account for when you are filling a material, right? We have a fill factor and cut factor. So it can be less if you have the material, because when you compact the material, the volume reduces and things like that. But let's just keep it as this for now. Okay, so still under this field, we are going to add the EG and the datum surface again. So what we'll simply do is to, you know, is to just okay, we are going to just reverse this. Since this one is below, this one is going to be above, and then this one will be below. So what are we going to do? We are going to just apply. Okay, all right. So then when we have done this, okay, we have just created a criteria. Now, sorry, there is one thing that you have to do before computing the material properly. Okay, you have to create sample lines, okay, and then create your sections. Okay, that was supposed to come before in the procedure, you know, after step 9. That's why it's all in step 9, so you do them together. Okay, but let's create cross section. That was the first thing we're supposed to do. All right, so let's add sample lines. You just go to under the home tab in this side, you find the sample lines, you click on the sample lines and then select an alignment. We want to sample on the road 1, so let's just press enter. Okay, then we select an alignment from this middle. Okay, we select okay, road 1, and then let's give it a name. We can just use the default naming style, and then we are going to allow everything here open. So let's just sample all this data. We want to sample everything. We want to sample the EG surface, the main corridor, and the main corridor datum surface. So we're sampling everything. So let's press OK. So we are going to be sampling by a range of stations. Okay, and remember my changes was at 20 meters intervals, right? Okay, so we are going to be sampling with 20 meters intervals. So let's check. We are going to select that from here. Okay, we are going to we are going to be sampling. All right, pardon me. Let's okay, all right. So okay, sorry, here. All right, so let's check by a range of station. Okay, all right. So when we choose this range of station, we are going to select the intervals. So as you can see, we have the station range. We want to start from the beginning of the alignment. We leave that as true. I want to go up to the end of the alignment. Okay, so the left swat width, that is how long from the center line is it going to go to the left. We are going to sample to the left. So already you know our width to the left is, one lane is 3.65, and then the shoulder is 2.75, so making a total of about 6 meters thereabout. So let's say everything want to sample like 15 meters to the left. Okay, I could have just left it at 20, but I can show you that you can actually adjust it. Make sure that it's beyond your corridor width for one lane. Okay, so let's say 15 meters. Okay, then you go to the width, and to the right swat width, and also put 15 meters if you wish. Okay, then the increment, all right, along tangents is 20, along curves is 20, along spirals 20. Great. Okay, so yep, so and we can add additional at some stations, but we don't want that for now. Okay, so let's just leave everything as it is now. When we just press OK, see what happens. Okay, it automatically samples. You see the blue lines. Let me escape this command. Okay, and then you see all these blue lines showing. Okay, all right. So as you can see, we have sampled all our sections at 20 meters intervals. Now what can we do with that? We can create section from that. So if you go to your section view, you go to create multiple views. Okay, once you've created your multiple views, you open it. Now you'll see for which alignment you select for road 1, and then you select the alignment collection. Okay, So you select this section placement. Now we are going to use production. Okay, if you want to use production, you have to select a sheet. Okay, you are going to select it in a sheet, but we are not going to use a sheet now because I don't want to go into all the intricacies that are involved in that. Let me just put it as draft. Okay, just paste it as draft. Now let's go to offset. Okay, let me just for your sake put this production. Okay, we can select a sheet. Okay, A0, A1, A3. You won't find A3. Okay, let me just tell you beforehand, I have to create it myself. So okay, let me use A3. Now if I must use A3, okay, there is something that I should have made, an adjustment I should have made. I have to make sure that my scale is the same with what we have here. So you see that A3 is 1:250 here. So let me close this back. I must make sure that I have 1:250 selected. But because you don't have this A3 sheet, I'm not going to use it. Okay, please pardon me, I'm not going to use it. So let me go to the section views, create section view. Let's just use the normal draft, okay, because you don't need to select the sheet in this one. So you go to offset range, leave it as okay, this shows this the sample line extents, the 15 we chose, both the swat width. Now let's go to elevation. Okay, well, let's leave it at automatic. Okay, then what are we sampling? We are going to view all these ones. Yes, we want that. So let's the data bands. Now if you want some data, because we have calculated our cuts and fills, we can add some data bands to it, but let's not add that for now. So let's just do create section view. Now you have to select a place where it will not interfere with your original drawings. Okay, so let's find somewhere here and put in our section sheet. Okay, so watch for it to come out. Great, so we have these sections. As you can see, this is how our section is looking like. Okay, now this is not a very great view because we are just using draft. That's why everything just comes in without title block, extent. When you are using that production, it will bring up a title block and just use, maybe it will group like 6 of them into one sheet. Yeah, so because you can see we have plenty. So if you keep viewing them, all of them one after the other, you would see it's showing you the cuts, it's showing you the fill, okay, for each of them, how it's looking, and the elevations by the side. You can adjust all these views. If it's not looking fine for you, you can click on it, on one of them, and then go to view group properties. Okay, you can select, for instance, if you want to change the style, let's say to lang desktop. Okay, let's say to another view. Okay, if you do that and then apply, okay, you can see this another view style. This one is looking more compacted and better. All right, so you can always adjust how this thing looks like by just creating the view that works. All right, so that is it. We also do the same thing for the row 2. Okay, that is by creating sample lines. We go to sample lines and just press enter and go to and click on row 2, press OK. So we still press OK, everything is by default. Now go to by range of stations again, then everything, I think we Civil3D again is merciful to bring the previous settings. So remember we did not put at beginning of station. Okay, all right, we in the previous one, but we needed it. That's why if you notice in the cross section in the sample view you won't see channel 00, but in this case let me put true here. Okay, to start at the beginning of the station, okay, and also at the end of the station. Okay, I press OK. All right, so if you can see, it has also created sample lines for that. So we now go to create the section view, create multiple views for it as well. So we are going to use row 2 this time, and then sample collection 3. That's the name automatically for the sample line associated with row 2. So every other thing, I think I'm going to leave it by default. So let me create the section view. Again, I find maybe to the right hand side of this and place this. Okay, so again I can choose how this changes. As you can see, this one is spanning all the way. That's because it is at our intersection. Okay, that sample line is somewhere here, so that's why you see the view was it's not showing you the shoulders and things like that. So you can monitor to see if there's anything that is not showing well in this section. So that is it. That is it. That is it. So we have created a section. Then we can proceed to computing our materials. So how do you compute your materials? Just click any of the sample lines, okay, and then go to compute materials. Okay, now we are computing material for road 1, and then we are using the sample collection line collection of this. So we press OK, and then once you do that, now because we have to we created a quantity takeoff criteria, we find that criteria, earthwork, cut and fill, and once you find that, you just use map objects with the same name. So it will map EG surface to EG surface, it will map datum surface to main corridor datum surface automatically. So once you have done that, okay, it will automatically compute your materials. Great. So allow Civil3D to complete it. Once it completes, great, the materials have been completed. Okay, if you want to view that, you can click generate volume report. So that is road 1, the sample line. So it named it automatically for us at material list 1. Okay, then you can choose the format. It's an earthwork. Okay, and then you can display the SMS report and then press OK. Not now. Oh, this does not look good. Okay, here is it. Okay, so that is it. So as you can see, we have changed 00 is not showing because I told you in the sample line creation we not check through for that road 1. So but basically you can see that we have our cut and then we have our fill. So somewhere here, all this way we are not having fill until somewhere here we have fill. So in the end, go to the last point, you will see that we have we are needing material. So this minus 3, this means that you need to fill. Okay, so that is it, cumulative net volume. Okay, because obviously you can see that our materials, this is what our material is. Okay, let's have, where's our cut, where's our fill volume, cut volume. Okay, so cumulative fill and cut. So let me now just go into explaining all these materials. Okay, so that is it. You can see the report. So let's go back. All right, we can do the same thing for row 2. Okay, we go to row 2 and then create compute materials. We have to select the sample line row 2. Okay, and then press OK. Okay, we now use our quantity takeoff criteria and then map objects and then press OK. We have created that material. So let's generate volume report. Okay, so and then you choose row 2 and then it automatically gives you the sample line collection for that and then material list for that, and then you press OK. Okay, this is for road 2. All right, so you can see it's quite short. So we have a fill volume, cumulative net volume. This is the fill volume, cumulative fill volume. This is cumulative cut volume. So you can see that the fill is less and then we have more cut. So we are going to be having more cuts in this section of the road. So, and that is it. Let's go out of this. So great. So we have computed our volume. Is that the last thing? Yes, we have calculated our cross section and computed material. So we have the step 10, which is to generate plots and report. Now in this one you can now do that by itself. Okay, I've done justice to this. So if you want to do, generate plots, let me just quickly run through that. You have to create on the output tab, you have to create viewing frames. Okay, if you are creating viewing frames, let's do for road 1 only this time, and then go to sheets. Let's do plan and profile. Okay, let's do a view frame group. All these things, let's leave them by default. Okay, and this one's still by default. Profile view, yes, everything. So let's create view frames. Great, you can see the view frames have been created automatically. So what will this thing do? You have to create view sheets. Okay, create sheets. So you are going to use the view frame that you just created and then create sheets out of that. Let me create the sheets so that you can see the drawing has to be saved. So I should look for somewhere and click on the screen, and then it will create the sheets for me automatically. Alright, so let's wait for that. So great, so it have created the sheets as a separate drawing. Okay, so it's saved somewhere in your file. Alright, so now if you click, let's say double click on any of the sheets, okay, you'll see how it looks like. Okay, it's opening up. Okay, all right. Okay, let me check this. So you can see it will automatically bring the plan above the profile. So sorry I didn't go through everything, but while I was creating the view sheets, I could hide some of the views. Okay, like here, if you can see the surface is showing, I would uncheck the surface. Okay, in that case, so that my surface will not be showing. I also uncheck my points so that my points will not be showing. Okay, so I'll just be left with only probably the corridor, or even the corridor. Sometimes I don't want it to show. I just want the center line and the offset alignments to show. It would have been done there. So in this plot, once you have done all these things, you can now print. Okay, right. So that is it for this section. Okay, so let's just go back to our drawing here. All right, so you could do that for row 2 as well, but I'll leave you up for that. You can just do that for row 2. Okay, so the next thing we are going to do is to create to generate our reports. Okay, so when you go to your toolbox, okay, you will find reports manager, check it. Then let's go to profiles. All right, this is the one I use. So the one that is the best for you to use is incremental stationing report. You double click on that. Okay, it will bring you up this. Okay, sorry, I need incremental station reports difference. All right, great. This is the one I would use. Okay, so let's do for road 1. Okay, so which profile? Okay, we need road 1 design profile. Okay, that's what we'll check. Okay, and then we need also the EG surface. All right, so we need it as an interval of 20 meters. Okay, 20 meters. All right, so and then let's just use the regular interval. Let's uncheck all of this. Okay, and then once we have done that, we press we choose where we want to save it. Okay, let's go to desktop. Let's save it as road 1 details. Okay, road 1 cut and fill, or let's call it road 1 design. All right, so let's say save, and then let's create the report. Okay, no existing ground elevation data reported. Okay, then no static profiles. Okay, let's continue. Yes. Okay, so yep, as you can see, this is showing you the eastings, the northings, the elevation for existing, and then the elevation for design. All right, this is the elevation difference automatically showing you, okay, for every all the changes from the change 00 down up to the last change. So this is what you need. You can export this as Excel, okay, and then this is exactly what you're going to give the surveyors. They will input these coordinates, and on these coordinates they will input this elevation design. Okay, this difference is just to guide them on knowing, okay, you need to the difference is okay, 0 meters below, so it's exactly matching the existing in this case. So but here the elevation, we are going 19 cm higher than the existing ground level. So with this you can even know how high or low you are going with your profile. Once you just look at it, you will scroll through. So here you can see it is a fill. Here is a fill, 1 meter, you're going 1 meter high. Okay, that's not bad. 2 meters even high. So but you don't want to go too high, let's say like 4 meters high in filling. So obviously I cannot see something like that. Or I'm having like 7 meters in cut, but remember, I did not design the profile accurately like that, painstakingly, just like I did with my alignment. So you can do that on your own, because if you're doing a live design, you have to do that properly. Okay, but of course that does not mean that there are no cases where you can cut 7 meters or 5 meters. Okay, it's depending on what is available. Okay, so that is what we all right, that's all for the class. So thank you very much for the opportunity, okay, to take you through all of these things. There are so many things to just go through. Okay, in fact, just alignment, we can spend a lot of time on it. So but this, I've just breezed through the whole design and shown you areas you can concentrate on making the design better. For instance, your views and styles. Okay, like all these views, they are not so nice, but you can create yours. You can always adjust how they look. And here in creating the section views, okay, you can see here is shaded. It's actually supposed to show red or green depending on cut or fill, but you can always do that. I'm telling you things that are obtainable. All you need to do is just click on anything, on any of the view, okay, play around with it, right click, and then go to edit view styles. So here you can play a lot with, play with all of this, okay, to make this view look better. Okay, once you are done, you can now plot it. Okay, remember we just do draft. Okay, if we did it in production style, it will automatically add a title block here for us, and then when we are creating the sheets, it will automatically lift those sheets for us. So yeah, so we couldn't go through all that. This is the much we could take for the class. Thank you very much for joining the class. I can't wait to see your designs. If you happen to do it yourself and send it to me, I'll be much happy to review it and then give you any comments that could help you develop yourself. Okay, so alright, like I mentioned, I'll be importing my templates so that you can see how I've adjusted all these views to look fine. So let me go to manage. I'm going to import my template. Okay, I have to save the drawing to do that. Alright, so once I do that, I create import. Okay, I have my templates. No, this is not the one actually. So let me go to my documents. No, not documents, my local disk. Okay, I have my Civil3D project. Away, I have my templates. Okay, I open it. Alright, so let me open that up. While it's opening, alright, it will allow me to import all the settings. Alright, so that is it. That's it. My profile, my templates is loading. Okay, beautiful. It's coming. Yep, loading. Template is simply all the design views that I've adjusted. So I'll just save those as a template. Okay, all right. So and then I'll import it into any design I'm working on, so that it will look good. So if you look already, let me turn this to 1:1000. You can see that in my templates, okay, I'm having, you know, some views. Let me right click on edit profile view style. Okay, let me go to profile view properties. Profile view properties. Oh my god, sorry, the profile view properties. So I'm going to collect my template. My template is this 25 meters interval. Okay, I usually work on 25 meters intervals, that's why we have it here. So let me press OK. Wow, you can see it looks finer right now. Alright, so even for this, I have a template for this. So I can go to edit label group. I can import my label set. I have it as HB label set. Okay, I can press OK. So if you look at it, it's white in color, showing you the ranges of the curve and showing you everything. So it's looking better already. So even the band set styles, okay, I have my edit band style. Okay, all right. So or rather, let me go to edit profile view properties. So when we go to bands, I have my own band styles. I call it HB band. Okay, so let me press OK. Great, you can see my band styles. Okay, it's showing you a very robust view. So, and as you can see, everything here is 0, showing the difference here is showing 0. Okay, between the existing and design is because I have not adjusted it. So let me go to the band styles again. Okay, when I go to the band styles, I have to select the profile 1 to be the EG surface, and then the profile 2 to be the design. I'll choose all the profile 2 to be the design. Okay, and then I'll press OK. So you see it will update it, so showing you all the cut and fill that is available here. Alright, I can do the same for all my section views, and of course manually add that here. I'm going to manually add that because I did not put that when I was creating. I'm just importing the styles now. But usually before I start the drawing, I import my styles and then work with it. I don't want to just bore you with that. Okay, it's just something. I'm just showing you the capacity of what you can do. It cannot just look as ugly as it was originally. All right, so that is it for now.
All right, guys, thank you for joining the webinar. Yeah, it was supposed to be live, but this is a recording, to augment for the inconvenient experience that we had earlier. So that was it. So it was quite a roller coaster, and there are so many things I could have shown you, but time will not suffice. Okay, to make it, I try to make it as concise as possible. But you have learned a lot. I believe even with this, you can get the ground running. If you're already in design, I believe you've added, and if you're just starting, this is enough for you to just progress. So I would like to see in my future class when I get the chance to put some things on it. All right, so this like for instance, I did not put culverts, but you see those places that I have streams crossing, and also the low points on my profile. Those are the places I put bus culverts. Okay, so of course I didn't mention that in this class. Okay, I mean to cover in this class, but it's something you know is part of road design. Okay, so I've only designed the road itself without the drainage, and all those things, but just know that it's included in the road design. So thank you for joining me in this class, the webinar. I would love to see you in future classes, and you can ask your questions in the class. So for some of you that indicated interest, okay, in my private class, all right, I've subsidized it, and I would show, I'll make a comment on that. Okay, subsidized for a limited period. Okay, so the link is right on the screen. Okay, so you can just pre-register and then follow the instructions that follows on how to join. So thank you, and see you all.